This is a quick video about one-step inequalities and how to solve them. We have to remember we're going to treat inequalities like equations. We will have a special rule when we talk about multiplying and dividing, but basically it's the same thing. What we do to one side, we do to the other. Our goal is to get that variable alone to find out what number goes in there to make the situation true. And we're going to use inverse operations to achieve this. So we're going to start with some simple equations such as e plus 4 is less than or equal to 14. What we're going to do is use inverse operations. So instead of plus 4, we want minus 4 because they are opposite of each other. And the reason we do that is because we want a zero pair. We want this to go away. We're left with just e. 14 take away 4 is 10. And because we're adding and subtracting, we're going to keep the sign. And we'll talk about multiplying and dividing later where things will change up a little bit. So when we check, what we want to do is just plug it in exactly the way it is and use order of operations. So we want the sides to be equal. 10 plus 4 is 14. This checks out. So this indeed is what we want. So we're going to put a 0 on our number line and the number 10, which is what we want. We notice that there's an equal sign here, so we're going to put a solid circle. It's going to be inclusive, and we want numbers less than that, so we're going to go towards the 0. So now we've solved it, we've checked it, and we've graphed it. So hopefully this idea, you'll see me run through 3 more problems with adding and subtracting, so it should make sense. So follow along with me. Here we go. I have negative 22 is greater than or equal to g minus 6. Don't let the variable on the other side get to you. We still are trying to isolate it. So we're going to isolate this variable, draw a line. Negative 22 plus 6 is equal to negative 16. Because we're adding and subtracting, we're just going to bring down that inequality sign. This goes to 0 and we're left with a g. We're going to check our solution. Negative 22 is equal to negative 16 minus 6. Following order of operations, negative 16 minus 6 is equal to negative 22. That checks out, so this inequality is what we want. We're going to go down to our number line here. We need a 0 and we need a negative 16. Now, because of the equal sign, we're going to need a solid dot at negative 16. And this is saying that we need numbers smaller than this because negative 16 is the largest. We want numbers smaller than that. So we want to go to the left in this direction to get all those numbers that are smaller than negative 16. Okay, we're going to take a look at it again. We're going to split our sides. We have x minus 5 is greater than or equal to 6. So using inverse operations, we're going to add 5 to both sides. What that does for us is gives us a 0 pair. We're left with x. 6 plus 5 is 11. We're adding and subtracting, so we're just going to bring the sign down. Check our solution. X minus 11. Oops, x. See, I started doing that. Okay, let's get that number in there. 11 minus 5 is equal to 6. 11 minus 5 is 6. This checks out. So this indeed is what we need. We're going to put the numbers 0 and 11 on here. And because the equal sign, it will be a solid dot. And we want numbers greater than 11. So those are found to the right of 11. Last one, solving of looking at adding and subtracting. We split our sides. We take a look. We have 11 is less than or equal to x plus 8. We're going to subtract 8 from both sides. Once we do that, our 0 pairs go away here. 11 take away 8 is 3. Less than or equal to, we just bring it down because we're adding and subtracting. We have an x. We're going to check our solution. So 11 is equal to 3 plus 8. Follow order of operations. It works out. This inequality is good. We're going to put a 0 and a 3. And we're going to see the equal sign. We got to put a solid circle there. And again, the x is on the other side. Don't be fooled by it. We say 3 is less than or equal to x. So that means we want everything greater than that. So we want to kind of go towards that greater side. So adding and subtracting, pretty straightforward. You just got to make sure when you're graphing, paying attention which way you're going to go. Now let's talk about multiplying and dividing. We get into a new rule here. And what the rule is, when you multiply or divide by a negative number, you have to flip over the inequality sign. Now, why do we do that? Why does this come up? So let me give you some examples so that it will make a little more sense. So when we do a regular equation with an equal sign, if I took the number 3 and I multiplied it times -1, it would become -3. So what does that mean on the number lines? Let me draw a number line here. I'm going to put the number 0, 3, and -3 on it. So what basically happened is I started at 3. When I multiplied by this -1, it made my answer become -3. So basically what happened is it swung my number all the way over to the other side of the number line. Now, this was going on with regular equations. Now, the reason we didn't talk about that is because when you have an equal sign and you flip over an equal sign, it's still an equal sign. But if you take a less than sign and you flip that over, it becomes a greater than sign. So now we have to talk about this. We didn't have to talk about it with equations, but we have to talk about it with inequalities. So the same is true if I was going to divide a number. So before I finish that, let's do this. Let me take -3 times -1, right? That's +3, which would swing it the whole other way again. Okay? Same thing's true, like I said a moment ago, about doing division. If I took the number 3 and I divided it by -1, it becomes -3. If I took -3 and divided by -1, it becomes +3. So basically, multiplying by negative numbers, dividing by negative numbers, swing the sides of the number line. And because it swings the side of the number line, we have to flip that inequality sign over. So let's take this and apply it. Let's do some 5 quick little problems here with 1 steps, just so you get a feel for things. And that way, get some practice on when do I flip it, when do I not. So let's get started. So here we go. We're looking at this equation. 3x is greater than or equal to -9. Same thing. We're going to separate our sides. We see 3 times x. The inverse operation is 3, dividing by 3, because 3 divided by 3 is equal to 1. And we know 1 times x is just x. -9 divided by 3, which is basically taking 9 negatives and putting them in 3 piles, I'm still getting a -3. So I'm going to ask myself, did I multiply or divide by a negative number? No, I didn't. So I'm just going to bring down my sign. We're going to check, just like we did before. 3 times -3 is equal to -9. And we know that 3 times -3 is -9, so it checks out. Unfortunately, there's no way to check the sign flipping. You have to look at it and see what's going on. So we need a 0 and we need a -3. And this is going to be a closed circle here. And I want numbers larger than -3, so I'm going to go to the right. Let's do it again. Let's make it a little more complicated. Let's get 1/4 y is less than or equal to 1/2. Well, we have to remember a couple things. First of all, I want it to equal 1. So I have to think about, what will I multiply 1/4 by to get to 1? Well, hopefully you remember the word reciprocal. When you multiply any number by its reciprocal, it will always equal 1, which is what we want to get. So when I see 1/4, or 1/4, I know the reciprocal is 4/1, or just 4. So I'm going to multiply both sides by 4. When I do that, I'm going to take a look and do some canceling, because I know 4 divided by 4 is 1. So 1 times y is just good old y. Over here, I'm going to change to some factors, and I'm going to cancel common factors. So then I'm just left with 1 times 2, which is equal to 2. So what did I do? I multiplied by 4. Since I multiplied by 4, that doesn't change the sign. It was a positive number. I'm going to keep it. I'm going to check my solution. So I'm going to say 1/4 times times 2. Got to start that over here. 1/4 times 2 is going to be equal to 1/2. So I have to remember, when I'm doing fractions with a whole number, I have to put it over 1. Again, I'm going to do my factors here so that I can cancel common factors. And I can see I have 1 times 1, which is 1. 2 times 1, which is 2. So this does check out. This is the right answer. And I didn't multiply or divide by a negative number, so it's not going to flip the sign. So I need a 0 and I need a 2. I'm going to put a solid whole dot at 2, and I want all the numbers less than 2, so I'm going to go to the left. Practice a few more. Here I have negative 5w is greater than 15. I want to do the opposite, which is dividing by negative 5. Once I do that, I know that negative 5 divided by negative 5 is a positive 1. 1 times w is w. 15 divided into negative 5 into 15 will give me negative 3. And did I multiply or divide by a negative number? I sure did. So I'm going to change this greater than sign to less than. And I'm going to go and check my solution. Negative 5 times negative 3 is equal to 15. Following order of operations, this is true. So this indeed is the correct answer. I'm going to put a 0 and a negative 3. And I want numbers that don't include negative 3, right? Because there's no equal sign. So it's going to be an open circle at negative 3. And I want numbers less than negative 3. So I'm going to go to the left. Okay, next we're going to try a couple more. Here we have x, a negative x divided by 5 is less than or equal to 0. Don't let things bother you. We can figure this out really super easy. Remember we said dividing by 5. So we would want to multiply by 5, correct? So multiply by 5. But we also want to get rid of this. We don't want the opposite of x. We want x. So we're going to need a negative out here as well. I'm sure some of you are catching on and knowing what's going to happen already. We've got a big one here, which is x. 0 times anything is 0, but we multiplied by a negative number. So we're going to flip our inequality sign over. We're going to check our solution. So we have 0, the opposite of 0 divided by 5. Is that equal to 0? Well, 0 divided by any number is 0, positive or negative. So that checks out. We're going to put a 0 here. We're going to include it because of the equal sign. And I want numbers larger than 0, so we're going to go to the right. One last problem. Let's see if everybody's got this. Separate our sides. We have 4f is greater than negative 12. So we're going to divide both sides by 4. Does that change our sign? Will that flip it over? We've got a giant 1 here. 1 times f is f, and negative 12 divided by 4 is negative 3. And I'm going to hope everybody said, no, it does not change because it's dividing by a positive number. So we're going to keep it. We're going to do 4 times negative 3 following order of operations. 4 times negative 3 is indeed negative 12. That checks out. So this is our solution for this inequality. We're going to plot it on our line here. We're going to have an open circle at negative 3 because we're not including it, and I want numbers larger than that, so we're going to go to the right. Hopefully this video has explained one-step inequalities to add, subtract, multiply, and divide, how we work with them, and when to flip the sign over. Good luck.